Hey there, welcome back to CMTEQ channel in this series of tutorial on the basics of DigSilent PowerFactory. In this tutorial, we're going to do a simple power system harmonics analysis, obviously using DigSilent. But before we do that, let's first try to answer a few fundamental questions about harmonics. What exactly are harmonics? Now, once you know what are harmonics in power system, the next thing you'll want to know is whether they are bad in your power system network, and also what causes harmonics in your power system network. That way you can try to mitigate factors and try to prevent harmonics from occurring in your power system network. And finally, we're going to look at the IEEE 519 standard that basically define the limits for harmonics in power system network. Basically, these standards tells you how much percentage harmonics in your network are acceptable, okay, before you can actually move forward completing the design of your system. Great. Now, having said that, let's now go ahead and define exactly what are harmonics in power system network. Now, as you can see here, we've got what is known to us as a sine wave. Right now, this sine wave here could be a representation of a voltage or current waveform with a fundamental frequency of, let's say, 50 Hertz or 60 Hertz. Now, it is in this background that we can define what exactly are harmonics, which are basically a sinusoidal voltage or current waveform whose frequency are integer multiple of the system fundamental frequency. So now, if this system fundamental frequency is 50 Hertz, then the harmonics is basically an integral multiplier of these system frequency. So now the third harmonics will then be the system frequency multiplied by 3. The fourth harmonics will be the system frequency multiplied by 5, and that will be an integral part of your waveform. Now that will basically be distorted, okay? That is why it is called harmonics distortion. Now, these harmonics current are basically caused by non-linear loads, right? So non-linear loads, we're going to look at that in a moment. They're basically loads that don't follow your sinusoidal waveform, okay? They basically try to deviate from the fundamental frequency, and they introduce frequencies that will look something like this, and as a result you're going to have a resultant waveform that will basically embed these harmonics waveform into your fundamental waveform. So instead of having something that look like this, now you're having something that look like this, and having either your third or fifth harmonics component integrated into it. So that is now your harmonic distortion. And often, depending on the system that you are busy working, you can have something that look like this with more harmonics component as an integral part of your fundamental waveform. So that is, in a sense, what harmonics are. Great. Now that we know what are harmonics in power system network, now remember, if you find value in this presentation, don't forget to give it a thumbs up and subscribe to CMTEQ channel. Now let us have a quick look at some of the effect of having harmonics in your system. Okay, now so if you've got something like this, you've got a nice voltage waveform but a completely distorted current waveform. Now as a result here, the power quality, which is your voltage times your current here, will basically be affected, okay? So now if you've got a bad power quality, obviously your system will not function very well, and as a result you're going to have an increase in heating, right? So your system, things are going to start overheating, okay? And as a result you're going to have an increase in system losses, okay? An increase in system loss, obviously for some of the equipment like rotating equipment, there will be a reduction in torque, okay? Because the power quality is bad, okay? And this will in turn decrease your system efficiency and overall power factor, okay? And also not forgetting the fact that harmonics, especially in transmission line, can cause high level of interference, right? Due to inductive coupling between the communication network and the power line. So you can have system interference that will basically cause disruptions, okay? And this will ultimately lead to equipment malfunction. So these are just some of the problems that you can have in your system because of a high level of harmonics distortion. So now that you know what are harmonics, the problem that harmonics can cause, now your next problem here is to find a way to mitigate this problem, reduce harmonics in your system, okay? Now, in order for you to find ways of reducing harmonics, you first need to know what causes harmonics in your system. Now, we said earlier that harmonics are caused by nonlinear loads that comes in the form of UPS and LED lighting, variable frequency drive, power converters, and welding equipment. But there is something common in all these type of load, which is the switching, right? These are all power electronics converters. Basically, the way these systems work is they rely in switching, so the load is no longer linear. It's basically a switching converter. Switch mode power supplies, the switch will be like a MOSFET or a transistor that will be working in high frequency mode. Now, these high frequency switching basically introduce noises and non-linearity into your system, and as a result, you're going to have a current waveform that looks like this instead of looking like these pure sinusoidal current waveform. Now you've got a current waveform that is distorted because of the clever switching that is happening here. But now, make no mistake, you've got power converters, controllers that basically have a power factor correction where the switching is controlled in a way that it tries to follow a sinusoidal waveform of the voltage so that it can minimize the harmonics, okay? So they are there, but still you're going to have systems that rely in switching converter that will have lots of harmonic distortions in the current that is going to be drawn. Now we know that harmonics are caused by non-linear loads, but also note here that linear loads are not only resistive in nature, right? You can also have a linear load that is purely inductive or capacitive. The only difference here will be the introduction of a phase shift in your current waveform, right? But the current will definitely be sinusoidal. It's not going to have a distortion like in non-linear load like these power converters that we just discussed here, right? Now, how do you limit these harmonics? Okay, we know that the IEEE 519 got some limitations of harmonics, limits which you should not exceed, because if you exceed this limit, as you can see, for bus voltage that is less or equal to 1 kilovolt, these are the harmonic limitations, and for every voltage level there are limitations that are actually enforced. Okay, now if your system does not adhere to this limitation, you basically will not have a license to basically sell these systems. Okay, so if you design a UPS or LED lighting that basically operating at these voltage levels, and if your harmonics, right, they don't adhere to this limitation, you basically not going to get a certification to put your equipment in the market, okay, because it's going to be a problem for the power system network. So you won't get license to sell it. You can maybe go in the black market if you want, but it will be problematic for you. So you need to ensure that you adhere to this harmonics limitation before you can get certification. But now, how do you limit the harmonics? Well, that is a subject for another tutorial, for another day. And once again, if you find any value in this presentation, please make sure you give it a thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. Since we know that harmonics of the order like third or fifth harmonics is basically the multiplication of your fundamental frequency, so what you can do if you don't want to allow these harmonics to infiltrate your system, you can create low pass filter basically filters that can basically eliminate those high frequency harmonics for entering into your system. So that's some of the things that you can do in the most simplest form to mitigate the harmonics into your system. Now, enough of the theory. Now let's go and have a look at how you can actually do an harmonics analysis with DigSilent PowerFactory.